tutorial by LearnFast Studios.
Welcome back. In this session, let us try to understand how we can perform linear search using Python programming. Before we implement the linear search algorithm, let me explain you by taking one example how we will be performing the linear search. The linear search is very simple process. When you are having the list of the elements, it starts searching for the given element from the first location till the last location. Once it finds the given pivot element in the list, it stops the process and returns the position of the presence of that pivot element. Once it reaches the end of the list, even then if it could not able to find out the given element, then it returns the negative result. That means the given element is not found in the list. For this example, we are having the list of the elements, 10 list of 10 elements, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. This is for the example I have taken. It need not to be always an integer values, a list, otherwise it can also be any object. For this sample, the element which I am looking for is 25. Now let us run the linear search and then check whether this 25 is present in our list or not. First it starts finding, pick the first element from the list. The first element is 10. It compares 25 with 10. Since both are not equal, then it will go to the next element. Now it compares with the 20. Since it is not matching, then it will go to 30. Here also the negative, hence it is 40. Here also negative, hence it will go to the next element 50. Likewise, it will continue further and reaches to the last element. Even the last element is not matching with the 25, hence it declares that given element is not present. We can also consider one more case where the element is present. For example, we want to search for the 20 in the given list. First, it looks for the element 10. Since both are not equal, it will go to the next element. Now it found that element at the second position, it returns the position 2 and then stops the process. This is the linear search methodology. In this linear search algorithm, as shown in the example, all the elements need not to be in the sorted order. The problem with respect to the linear search is, as the number of the element increases, in the worst case scenario, the time complexity will be in the order of n. That means, for example, if you are having 1000 elements, then it may take the 1000 time quantities for the searching process in the worst case scenario. So that is the biggest problem with respect to the linear search. Let us try to find out what are the other ways how we can optimize this linear search in further sessions. But for this session, let us try to program the linear search algorithm. Let me remove these two. To perform the linear search algorithm, we need to have the list of elements. Further, let us try to read the elements and then write the driver code first. Initially, let us try to read how many number of elements are present in the list. Let us store it in n equal to int input of enter number of elements. After reading the size of the list, let us try to read all the elements using this n. In order to perform the repeated task, we'll be using any looping statement. In this case, we already know how many number of times we need to repeat the task, hence we can go for the counter control logic. The looping statement that sound that the looping statement that supports the counter control logic is for loop. Hence, for our case also, let us try to use the for loop. In order to store the list of the elements, let us take an empty list with the name Ellie, and let us try to read elements and then append those elements to our list. In order to read n number of elements, let me write down the code for that. For I in range of n, starting from 0 to n minus 1, the statement which is written inside the for loop will now get executed. Now let me append whatever the element that we read from the keyboard to our list. To append means we are adding the element at the end of the list. Append is the function which is available in list data structure in Python. We can also make use of the insert function, but for the time being, let us try to use the append function here itself. So Ellie dot append of, now whatever the element that we read from the keyboard, let us try to append. Let me say int input of enter element. This reads, every time this reads an element and try to add that to our existing list, by means of which we are able to read n number of elements to our list. Once we read the elements and then we read the n value, then let us try to read what is the element that we are looking for. Let me name it as a pivot element. Pivot equal to int of input of enter pivot element. Since we store all the elements as an integer values, we read even the pivot element as an integer value. In the real-time scenario, it need not to be the case that we need to read the elements. Sometimes, for example, if we are having the list of the contacts among which we want to search for a particular name and then obtain what is his contact number. In this case, instead of the reading the elements, it can fetch all the data from the file and then the pivot element will be a contact name. Now let us try to code our linear search algorithm, where this linear search algorithm is going to take two arguments. Let me define one function for the linear search. To define the function in the linear search, we use def linear search of elements, comma, pivot. Once it receives the elements and then pivot, now we need to search starting from the first location till the last location in the element list for the pivot. So let me take for I in range of len of LE. Let me check element of I is equal to pivot or not. To check whether both are having the same quantities or not, we will be using the if statement. If the LE of I is equal to pivot, that means the given element is present at that particular location. So we can return the value of I plus 1. Why I am returning the I plus 1? Because since the first element is stored at the location 0, second at 1, third at 2, if we find an element at second, that means that will be in the order of 3. So that is the reason why we are returning the value I plus 1. By the end of this for loop, if we still continue in the linear search function, that does mean that we don't find the given element in the list. Hence, we can return a negative number. So return -1. It need not to be the -1 in all the cases. Instead of -1, you can also alter the value to any negative number or any other number, which significantly denotes that there is no element present in the list. Now let us make the call to this particular linear search function. In order to make the call, we have to use the function called linear search of. You need to pass the elements which we read from the keyboard, which are there available in the list, and then pivot. And once this linear search executed, we are expecting the result to be stored in result variable. Don't get confused that you need to use only these variable names LE and then pivot. You can also change. It is the terminology error. So let us go ahead and then now once you call this linear search function with these two parameters, now it will pass these parameters and then assign that to this particular LE as well as in this particular pivot element, and then performs the process and then returns the result. Once the result is obtained, that result gets stored in the result variable. Now let us try to display what is the result. So we have to display the result if and only if the result is non-negative number. So if the result is not equal to -1, print the element found at location %d percentage result. Otherwise, we simply display element is not present. That's it, guys, for this session. Let us try to execute this code and check whether our intended work has been done properly or not. Now it is asking me to enter number of elements. Let me enter 5. Suppose 15, 4, 3, 27 and 9. So let me enter these 5 elements. We are having 15, 4, 3, 27 and 9. Let me enter the pivot element as 3. Now the expected result will be 3. Why? Because this 3 will be first compared with 15, next with 4, next with 3. Hence it found the exact match with the pivot, then it will result the position. So the element is found at the location 3. Let us also verify within one more failure case. Let me enter 4 elements 10, 20, 30, 40. Now let us pass the value 50. As you can easily understand that the given 50 element is not present in the existing data list. Hence, we are expecting that element is not present. That's it, guys. With this, we have successfully implemented the linear search methodology. Thank you and have a great day.